all of we know that brain is a vital organ when it comes to the concept of consciousness, and and to see brain at atomic level, it's a complete quantum mechanical description out there. So in this video, uh, I'll be talking about the physics that's involved in neuroscience, and what's the role of physics in the field of neuroscience, the science of brain. So to introduce the concept here, this neurophysics, uh, the physics of neuroscience, it is an it's a field that explores the complex and fascinating relationship between physics and brain. It seeks to understand brain function, cognition, and behavior through the principles of physics, and the gateways, opening the mysteries of neural networks that originate over thoughts, emotions, and actions. So, by combining the rigor of physics with the complexities of neuroscience, this neurophysics, it opens a very new friend in understanding the physical basis of perception, neural dynamics, and even the potential role of quantum mechanics in brain function. So to start with, it's clear that one of the key aspects of neurophysics, it is to investigate the electromagnetic phenomenon in the neural activity. The brain's communication and information processing heavily rely on certainly it relies on electrical and magnetic interactions that keep on happening there every time. And neurons, these neurons communicate through these electrical signals known as action potentials. These action potentials, they travel along the axons of neurons. So these electrical signals are modulated by some ion channels, specialized proteins that control the flow of ions across the cell membrane, thereby influencing the neurons' excitability and firing rates. This neurophysics also explores the role of neural oscillations, the oscillatory motion of these neurons. These 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 rhythmic patterns of electrical activity that are observed in the brain, and there are techniques that are utilized to measure these activities that are going on in the brain. The quantum brain dynamics, beyond classical electromagnetism, and neurophysics focuses into the well of quantum brain dynamics. At the microscopic level, the quantum phenomenon, they raise interesting questions about their possible influence on neural processes. And these influences could be the result of quantum entanglement. It's a phenomenon where particles become inseparably linked, and quantum coherence, where particles behave as waves, or the two quantum effects that might play a role in brain function and cognition. So although the exact implication of quantum mechanics in the brain, it remains a topic of ongoing research and debate. It presents exciting possibilities for understanding consciousness and memory. Imaging, it's one of the basic criteria of physics, and I think physics has played an important role in developing the technology and utilizing that technology to peep into smaller and smaller and smaller things, from microscopes to telescopes. And in neurophysics, neurophysics has also made a significant contribution to imaging techniques, thereby enabling non-invasive observation of brain activity, and taking the photographs through functional magnetic resonance imaging, and positron emission topography, and these technologies, they offer a very big gateway to understand the activity of activities that are going on in the brain, and they offer the insight into the brain function during various cognitive tasks and emotional states. These neuro imaging techniques have revolutionized neuroscience, allowing researchers to explore the brain's structural and functional activities. And I think moreover, this neurophysics plays a vital role in the development of brain mechanics interface. This brain mechanic interface translates activity into actionable commands, enabling paralyzed individuals to control external devices, and even robotic limbs. And the kind of thing that was used in case of Stephen Hawking. Everybody knows he was in a very complex paralytic situation, but the technology was used where the activities of the brain could be translated into the preferable language, and he could do a lot of research, even being bodily paralyzed. His brain has given a lot in terms of understanding the nature. So, this the successful integration of physics principles with neural decoding algorithms. It should be a key pattern of research, and it should go in a very strong dimensions. And they should the two should incorporate things in such a way that the outcomes are extreme, so that one can have better understanding of the activities of the brain, and the impulses that are generated by the brain, and these impulses are giving a kind of translation to the actions that a human being or an animal does. Implications for medicine and artificial intelligence. The insight gained from this physics of neuroscience, it holds great promise for medicine and healthcare, and understanding the physical basis of neural disorders like epilepsy, Alzheimer diseases, Parkinson diseases, can lead to more effective diagnostic tools, and possible potential treatment. Additionally, this neurophysics has implications for the field of artificial intelligence. The brain's computational power and efficiency have inspired the development of neuromorphic computing, where artificial intelligence systems are designed to mimic the neural networks in the brain. This correlation between neurophysics and artificial intelligence can lead to more biologically inspired algorithms and cognitive computing models. And to conclude this presentation, this neurophysics, it represents a fascinating and ever evolving branch where physics and neuroscience can strongly intersect. And as we continue to explore the physical basis of brain function, we gain valuable insight into the essence of human cognition and consciousness. This interdisciplinary approach of neurophysics holds the potential to reshape our understanding of the brain, uh, and, um and puts us in a new uh, era of neuroscience and technological advancements. And embracing this relation between physics and brain, there is always an enigmatic